The common oxidation numbers of the elements exhibit periodic trends. For example, the common oxidation numbers of the alkali metals are all 1, while for the alkaline earth elements of group 2, they are 2. These values correspond to the numbers of valence shell electrons in the atoms of these elements. As we move from left to right across a given row, the maximum oxidation number observed increases regularly to +7 at manganese. From lithium to boron, the commonly observed oxidation number increases from 1 to 3. Carbon can have more than one oxidation number. For example, -4 in a covalent compound such as methane, CH4, +2 in a compound such as carbon monoxide, or +4 in a compound such as carbon dioxide. Nitrogen similarly has several different oxidation numbers in the various compounds in which we find it, ranging from -3 in a compound such as ammonia, NH3, to +5 in a compound such as nitric acid, HNO3. The more electronegative elements, oxygen and fluorine, show only negative oxidation numbers in their commonly observed compounds. The elements of the third row of the table show a similar variation in oxidation numbers. Notice that the most positive oxidation number observed for each element increases steadily in moving from sodium to chlorine. Notice that chlorine and sulfur have positive oxidation numbers. These occur in oxides and fluorides of these elements, because chlorine and sulfur are less electronegative than oxygen and fluorine. In the fourth row of the table, we encounter the first transition metal series. Notice that the maximum oxidation number increases regularly to manganese. As we move beyond manganese, the most common oxidation states for the transition metals are +2 and +3. For the nonmetals in this row, the observed oxidation states are very much like those of the corresponding second row elements.